I've started recording. It is
Okay, thank you,
recording.
Margaret. Yeah, thank you. Yeah, yeah, David, you can.
Right. So a little bit of background about this is that there's the two big compliance issues is ITAR and EAR compliance. And basically this sort of says that any sort of unauthorized disclosure of technical data, this could be quotes, programming languages, anything like that, through unsecured file transfer, improper access, or misclassified export categories. What that means is like we said it was not compliant, it wasn't needed, but it was, sort of thing. Even that sort of thing can result in civil penalties, liability, and you can lose your certifications. So this has been sort of a growing issue. And so there has been some work done on this. There has been some work that's confirmed that like natural language processing classification, anomaly detection, and even automated evaluations can be validated, and they do work. The problem with that is that there's no sort of integrated platform. It doesn't go from, you don't go from your quote into that sort of thing. It's all done like as in I submit a quote and then they're trusting me, and the company's trusting me to make sure that I'm on top of it, that sort of thing. And so with that, there has been some need for an integrated platform, but as of now, there hasn't been a really good unified workflow. And so the three big literatures that I pulled from this comes from a little bit of different things. Azim's reading is all about legal and regulatory. So they did a lot. This is where a lot of pretty much just automating GDPR completeness. GDPR is something that's in the European Union. It's really strong. They're really, really private people. And so they wanted to use this sort of thing. They had very basically 10 classification solutions. And they said, okay, I want you to see, like, can all of these algorithms correctly identify what needs to be protected and what doesn't need to be. And what they ended up finding out was that this process could be highly automated, but there was always going to be the need for human review for false positives or anything like that. Now, in the supply chain world, Balkan and the Kuyas had attempted to do a systematic review of monitoring pricing and purchasing habits of suppliers. And they used essentially, they used a different type of machine learning and basically used it to say, okay, monitor and make sure that these suppliers are doing what they're supposed to be doing. They're not charging us too much out of, what attempt they're trying. And what this kind of boiled down to was that the all the AI things could handle routine tasks, but there's always going to be that need for human AI hybrids, especially at higher levels. And then finally, under Yun Kim, this is in the construction world. I use this one to show that this was used for an automated monitoring of jack supports. So basically what they did is they set up all these cameras to basically monitor and make sure that all the supports on this construction site were correct and they were valid and they were not causing any problems. And this worked really well. This was very highly automated and there was only a little bit of manual verification used for edge cases. And again, with the edge cases, they were like misclassified and then it was raised to a human. And so how did I do this? I broke this down into three sections. For the platform layers, I have created a React front end. I implemented, there's a REST API in the middle. This does all the authentication, routing, and encrypted transfers. And this REST API also orchestrates all the machine learning services below. And finally, for the backend, I used a Raspberry Pi 4. This is just a self-hosted Linux stack. This was built completely to be modular because the assumption is that if this works, eventually this would be migrated into the cloud. So for example, AWS GovCloud is a very big popular with federal suppliers. And I wanted to make that as simple as possible. Now, the three capabilities that I set up were NLP export screening. And what this would do is every document when you would submit in through the website, would analyze all the document categories. It would turn it into keywords, and then it would try to detect if the category needed to be export controlled or not. If it thought,
David, oh, sorry to interrupt. You have 5 minutes left to explain about Capstone.
I'm sorry, how much?
You have 5 minutes left.
I'm sorry, I don't understand.
Oh, can you hear me?
Yes, I can hear you.
Yeah, so you have 5 minutes left to complete this project. Explanation time.
I will. Okay, I had 10 minutes.
Yeah, I'm just like making sure you guys, like,
Okay. That's fine. I will continue. Very basically, this was just used as 3 layers. I used the front end, the REST API. The REST API would call into the 3 machine learning services. And then basically, if anything was detected as an anomaly, it would be flagged and alerted a human and for human in the loop. And as always, everything is marked in an audit. Everything that goes through the system is logged and outputted to the dashboards. How did I do this? The implementation for this was not very straightforward, but I broke it up into 3 things again. For the export classification, I used the TF-IDF. I used, very simply, about, excuse me, this would call the website of the federal website for export classifications, would download the data, parse it into different categories, and then it used about 100 entries to test against it. And so very basically, if it was confident that this product was ITAR controlled or EAR controlled, it would flag it. And then if it wasn't sure, it would send it to a user. And that's the same way with the price anomaly detection. It basically compared the price baseline versus what we assumed is a 20% inflation period, and would say, okay, if it's flagged, send it to the user. And finally, for the keyword harvester, this also used the eCFR to do that. Data collection, like I mentioned, I used for my data sources, I used the control list and harvested it as an XML, and then used it to manage all of these. And so for that, the export classification data set has about 650, and then I was able to use that against 1,000 part numbers to essentially run sort of test. And so skipping a little bit further ahead in the data analysis, I found that it was very, very confident in its pricing anomaly detections. It had an 89% accuracy with 100% recall. And one of the big wins for this is that the misclassifications was only 10 out of the 95, and it always caught itself. It wasn't sure. It would flag it for review and send it to the user. And so then, very basically, this shows that, like, if we put it all into one pipeline, it really works to do this sort of thing. And this is going to be able to this is so modular that it will be able to go into the cloud without super big designs. Finally, just some expanding the baselines for future work. I would really like to work on the drawing change detection. I did not get time to do that. I was only able to work on documents. Demo video. Can everybody hear that?
Yeah, I'm not hearing the voice.
Okay.
It's fine, David. Like, you can just show the demo. We can probably install it.
Yeah.
Just maximize it.
Okay.
It's okay. Yeah, you can keep going.
It's not letting me. I apologize.
It's fine. It's fine. Oh, yeah, it's pretty
Okay.
good, David. Uh, what do you think like what is like do you face any challenges while collecting the data set? Because you told me like you're working in with Raspberry Pi as a backend. For machine learning, I think it'd be difficult to get or like collect the data sets. Like, can you please explain about like how did you do like face all those challenges?
Are you asking how like the challenges to get like to process the data on the Raspberry Pi?
Yes, yes. I'm just like
So
wondering.
yeah, so it is a little difficult, but the main issue I was having was that, of course, anything government related, it's never easy. And so
Yes.
I had to create a way that my essentially scraper would be able to detect when something changed in a classification. So if the government added or denied a category, that sort of thing, that was the biggest challenge. And
Hmm.
I really just solved. I didn't really have a lot of time to solve that problem, but what I did was on every refresh of every time the Raspberry Pi started up, and within every like 12 hours, it would go scrape the same data, the same websites that I had given it, and make sure that it was still the same. And then if it was changed, it would update it. It would say, okay, something changed, back it up, refresh it.
Yeah, I think it's pretty good project. I really like this project. I just want like for my personal thing, yeah, if you don't mind, like you just share the project. If you don't mind, you can share it in Teams. The presentation or demo. That would be great for me. Even I do have
You-
a Raspberry Pi. I probably also work on this.
oh yeah.
Okay,
So you just wanted the website, or you just wanted the demo.
and you can share like what do you think would be great to me. And yeah, thank you, David. So hey,